All right, so this last problem, we're almost done. Yay! Okay, so the first thing we need to know in order to do this one is we need to know the difference between a rigid and a non-rigid motion. Or sorry, transformation. So we know that a rigid transformation basically is the same size and the same length of the sides, as well as all the angles are the same angles. So these are examples of rigid transformations, translations, rotations, and reflections. Those are rigid because the length of this side of the triangle is going to be the same length as this one. So the triangle is congruent because all the side lengths are going to be the same and all the angle measures are going to be the same. So if let's say this is 60 degrees, it doesn't look like 60 degrees, but let's just say it was, and that one would also be 60 degrees. So the triangles are congruent. And then a reflection is the same thing. This length is going to be the same as this length. Same thing with the angles. That angle is going to be the same as that angle. And same thing with rotations. This length, whatever it happens to be, is going to be the same size as this one, as well as the angles are going to be the same degrees. So basically, a rigid transformation has the same size of the sides, same size of the sides and angles. Okay, so they have the same size, they have same sides, same angles. Where a non-rigid basically takes something and it either shrinks it or enlarges it. Or maybe it even changes the whole shape. So it was a triangle and all of a sudden now we're a rectangle. But so if you were to measure that, I don't know how long it is, but let's say it's like 3 and you go over here, well, that's definitely not 3. Let's say it's 9. It's blown up. Okay, so that is a non-rigid transformation. It's called a dilation, this one is. We haven't really gone over how to do dilations yet. So the length is not preserved. All right, so the first thing you want to make sure you do when you're looking at this problem is, hey, let's just compare from A to B. We can actually calculate how long that is. That's 1, 2, 3, 4. If we go from here to A prime to B prime, it's 1, 2, 3, 4. So we see it's the exact same length. So we know the transformation shown is a rigid motion, and the reason for that is because it has the same lengths and angle measures. Okay, so the angle of this one, angle A, is going to be the same as angle A here. So it is a rigid motion since the same lengths and the same angle measures. Where if we got something that looked like this, that blew up, or maybe it shrunk, it would be it's not a rigid motion because it does not preserve length. All right, that's the last one. Remember, if you did not score a 75 or higher on the test, you do need to retake it. And so make sure you watch these videos, do the practice, learn from your first mistake, and then that way you can do better. Thanks for watching. If you need help, make sure you contact me.